let's continue with the chapter Real Numbers. In the previous episodes, we have learnt about Euclid's division lemma and fundamental theorem of arithmetic. Today, here we shall discuss about irrational numbers. What is an irrational number? A number S is called an irrational number if it cannot be written in the form P upon Q, where P and Q are integers and Q is not equal to 0. Some examples of irrational numbers with which you are already familiar are root 2, square root 5, square root 13, pi and 0.10, 110, 110, 11110, etc. Before we prove root 5 as irrational number, let us look into an interesting theorem which states that let P be a prime number. If P divides A square, then P divides A, where A is a positive integer. We shall make use of this theorem in proving that root 5 is irrational. Here, let root 5 be a rational number. Therefore, we can find two integers A and B not equal to 0 such that root 5 is equal to A upon B. Let A and B have common factor other than 1. Then we divide them by common factor and assume that A and B are co-prime. So, A is equal to root 5 into B. On squaring, we get A square is equal to 5B square. Therefore, A square is divisible by 5 and it can be said that A is divisible by 5. Let A is equal to 5k, where k is an integer. On substituting, we get 5k whole square is equal to 5b square. What does this imply? B square is equal to 5k square. This means that b square is divisible by 5 and hence b is also divisible by 5. So, this implies that A and B have 5 as a common factor, which is a contradiction to the fact that A and B are co-primes. Hence, it cannot be expressed as P upon Q, or it can be said that root 5 is irrational. Is it clear? So, students, let us look into another question. Prove that 3 plus 2 square root 5 is irrational. Let 3 plus 2 root 5 be rational. Therefore, we can find two integers A and B not equal to 0 such that 3 plus 2 square root 5 is equal to A upon B. So, 2 root 5 is equal to A upon B minus 3, which can be rewritten as square root 5 is equal to 1 upon 2 into A upon B minus 3. Since A and B are integers, 1 upon 2 into A upon B minus 3 will also be rational and therefore, square root 5 is rational. This contradicts the fact that square root 5 is irrational. Hence, our assumption that 3 plus 2 square root 5 is rational is false. Therefore, 3 plus 2 square root 5 is irrational. Let us look into another question. Prove the following are irrationals. First one, 1 upon square root 2. Let 1 upon square root 2 be rational. Therefore, we can find two integers A and B not equal to 0 such that 1 upon square root 2 is equal to A upon B, or taking reciprocal, square root 2 is equal to B upon A. Now, B upon A is rational as A and B are integers. Therefore, square root 2 is also rational, which contradicts the fact that square root 2 is irrational. Hence, our assumption is false and 1 upon square root 2 is irrational. Let us look into the second part. 7 root 5. Here, let 7 square root 5 is rational. Therefore, we can find two integers A and B not equal to 0 such that 7 square root 5 is equal to A upon B for some integers A and B. So, square root 5 is equal to A upon 7B. A upon 7B is rational as A and B are integers. Therefore, square root 5 should be rational. This contradicts the fact that square root 5 is irrational. Therefore, our assumption that 7 square root 5 is rational is false. Hence, 7 square root 5 is irrational. Let us see the next part, 6 plus square root 2. Let 6 plus square root 2 be rational. Therefore, we can find two integers a and b where b not equal to 0 such that 6 plus square root 2 is equal to a upon b, or square root 2 is equal to a upon b minus 6. Since a and b are integers, a upon b minus 6 is also rational, and hence square root 2 should be rational. This contradicts the fact that square root 2 is irrational. Therefore, our assumption is false, and hence 6 plus square root 2 is irrational. Now, it is time to take assignment. Take down first question. Prove that square root 2 is irrational. Question number 2. Prove that square root 3 is irrational. Likewise, question number 3. Show that 5 minus square root 3 is irrational. Question number 4. Show that 3 square root 2 is irrational. So, students, we have learnt in this episode how to prove the irrationality of numbers. I hope you have understood. Please do these homework questions so that you can practice and learn the concept. Thank you.